Hi there, how are you doing? In this video, we'll talk about different database objects that can be created to store the data in Oracle database, right? The first one is tables. All this while you have been talking about, and this is something bread and butter for any database developer. So, a table is an object which can store the data ultimately, and it contains the data in the form of rows and columns. The next thing is partitions. So a partition can be done on top of a table or on top of an index. So what do I mean by this? Let's say that you have a huge table and that you're having tough time to retrieve the data from the table. Then ideally you can partition the data based on a reasonable column. For example, you can partition the data based on country name, or you can partition the data based on the date range, or you can partition the data based on some columns which can have the unique values, less number of unique values, right? So we can partition the data, and the similar way even indexes can also be partitioned, which is very less known concept for any database developer. Then we have something called table spaces. This is something we already discussed in the previous video. So a table space is a place where the exact, data logically gets stored within the database, but it's not the final location. A table space always refers to a database file called as data file, and the data file is the actual file that gets stored in the physical hard disk drive, right? And then we have indexes. So indexes are a kind of objects that are created to quickly retrieve the data. In case of indexes, we will not be having entire data stored. Instead, whatever the column on which the index have been created, or set of columns on which the index has been created, only those columns and the corresponding row IDs are stored in its memory, so that it helps to quickly retrieve the data. And then we have index organized table. So if you look at the name, index organized tables, so here all the columns of the table are indexed together, so that you don't need to really go to hard disk and then read the data. Instead, your data is stored as an index itself. So the next thing, external tables. So this is one of the feature that is supported by Oracle database, and there are features similar to that in other databases as well. Let's say that you have a CSV file which is available on your hard disk, and then you are trying to read the data from the file. Ideally, you need to load into the database, and then you can start querying it. Instead of that, you can actually create a table, and you can specify it as external table, and then you can define the properties how the data is stored in the file, so that you can straight away query the data from the database without going to the file or without loading the data from the file to the table, right? It's called as external table. And similar to this, we also have something called a SQL loader, but we don't create an object over there. We just use the SQL loader option to load the data, whereas external table can be used to query the data from the file directly without loading the data from file to the table. Then we have something called as nested tables. So this is something I have already part of previous video when I was talking data types that are supported by Oracle. So nested table is also a kind of data type. However, it itself is a table. It can also store the data. And then we have schema objects. So something called as materialized views, and then views. View is a virtual layer on top of a table that can be created, or on a set of tables in the form of a query. As and when you query the view, what it does is it will execute underlying query, and then it will get the data. So that's called as view. We will talk more about it later. But we also have something called as materialized view. So a materialized view is a view which stores the data in its own memory instead of getting the data from the underlying tables as and when we query the view. So that's the basic difference between materialized view and views, and we'll talk more in the next sessions, and how they differ, what are different options, how materialized view will help us save the time, and several other aspects. Then we have something called as synonyms. A synonym is at another object on top of a table that is created, and there are two ways. Like we have something called as private synonym and public. We'll talk more about it, but consider that synonym is an alias name for a table. And then we have sequences. So sequence is a kind of object which is used to provide the incremental values. Let's say that I want to insert a unique value in a column always, as in when I insert a row into the table, but I don't want to insert the unique value manually, then we can create a sequence and we can say that start incrementing the value of the sequence every time by one, so that it will keep giving us the value always incremented by one, which means that it's not going to duplicate the data, but there are several attributes while creating the sequence, and we'll have some dedicated time to talk about it later on. The next thing is constraints. So a constraint is at another object which is created on top of a table. While creating or after creating the table, we can add the constraint. So basically, this is to enforce the integrity or the rules how the data should be in a table. Let's say that we don't want to insert the duplicates, or it should not have null values, or whatever the values we have in the column should always be there in another table as well. Likewise, if we want to enforce any sort of integrity rules or any rules, then probably we can use constraints. We'll talk more about it later on. And then database links. So database link is very in other databases, like for example SQL Server, it's called as linked servers. So what it means is, let's say that you have an Oracle data, I mean, you have two Oracle databases, and they both domains, and you want to the tables from both the databases together and then generate some sort of report. Then ideally what you have to do is you have to take the data from database A to database B, or you have to take it vice versa, right? And then you can join the tables together. Instead of that, if we create the database link without moving the data or without copying the data from one database to another database, we can actually access the data virtually from both databases together and then join them and then generate the reports. So database links are really useful, but comes with some sort of performance issues at times. Please exercise it and use it wisely. Then we have something called as directories. So directories is nothing but, let's say that you want to read the data from a file. The file has to be located somewhere, and how does database will know like where exactly the file is located? In that kind of situations, we create a directory and say and point directory to the specific location on the hard disk, and using that directory we can create the external table or SQL loader and then read the data from the file. Only thing we have to make sure is that the path that we specify where the file is stored is accessible to the database, right? And directory is just a virtual name, just like table how we create it. In the similar, we create the directory and we specify the path, right? So these are different data store objects that can be created in Oracle database. In our next video, we'll talk about PL SQL objects that can be created. All right, till then, have a good day. Bye bye.